All right, well, it is time, so we will get started on time because we want to be conscious of everybody's time. But I just wanted to thank everybody for joining us, and then I'm going to turn it over to Andy. And if you guys wouldn't mind turning off your cameras or your microphones so we just don't have any feedback. And if you have any questions, please feel free to put them in the chat. And with that, I'm going to turn it over to Andy. So thank you, everybody.
Thanks, Gabby. Hi, everyone. I'm Andy McMahon. I'm one of the co-PIs on the Create Energy Center. I'm based out of Central Carolina Community College in North Carolina, and I will be providing the introduction to today's talk of the Innovation Series, entitled Using Generative AI for Data Visualization in Energy Systems and Sustainability Education. Our presenter, Dr. Yining Yu, will be telling us about how he uses that work in his daily teaching. Uh, Before we get there, though, I do want to take a few moments and quickly let everyone know about resources that are available on the createenergy.org website. This webinar will be hosted there along with all of our other webinars and a wide variety of resources for faculty to use as well. So I encourage you, if you have not been there before, please go check out all of the resources on the Create Energy webpage. We do have one quick ask if you're willing to participate. We are currently in the cycle of drawing up a refunding proposal for the Create Energy Center, and we are trying to get as much feedback from industry professionals and faculty as possible to help us guide what we are going to do in the next 5 years. Gabby will be putting these links in the chat. Please, if you have a moment, please fill this out. It's not a long survey, and it would be greatly appreciated and help us guide the future of the Create Energy Center. We do have a few more webinars coming up here in the next couple of weeks. We have one on May 8th, which will be teaching energy storage through pumped storage systems. And then on May 15th, the University of Arizona FFA Agricultural Mechanics Career Development Event, talking about their KidWin PVC Wind Turbine Challenge. So both of those are exciting and hope you can join us for those. And if you are not familiar and you would like to, and you're interested, please check out the Create Energy website again for more information about our upcoming summer workshops. We have quite a few. We have one at Hawai'i Community College at the beginning of June on energy storage systems and e-rides, which is an electric scooter. We have one at Central Carolina Community College for the North Carolina STEM Educator Energy Institute that is not restricted to North Carolina educators. It's just hosted in North Carolina, and that's in late June. And then we have two in-person workshops in Madison Area Technical College later this summer, one in early July, our Solar Institute, and then later that month, we have the Solar Plus Storage Institute. So a lot of really exciting in-person, hands-on workshops coming up across the country. So if you have not or you're interested, please check that out and see if there's still room available. All right. Well, today's presenter, Dr. Yining Yu, is a physics and astronomy instructor at Hawai'i Community College. He teaches various levels of introductory physics, energy and sustainability, and astronomy coursework. He specializes in active learning pedagogies and open resource curriculum development and seminar-style classes. Trained in theoretical physics at the University of Florida, his research interests include interdisciplinary fields of particle phenomenology and condensed matter physics. Please join me in welcome Dr. Yu as our presenter for today's webinar.
Thank you, Andrew. Thank you, Andrew, for the introduction, and it's a pleasure to contribute to the CREATE program. Let me share my screen. So today I'm going to talk about some active learning pedagogy and data visualization for the energy systems and sustainability education. And let me start with another brief introduction of myself. I teach physics and astronomy at Hawai'i Community College in Hilo, Hawaii. And I want to briefly start with the narrative of my story teaching at community college. I teach a variety of courses, Physics 105, energy systems, or sustainability. It's kind of weird to have a slash in the title of a course, but it's a historical reason. And my task was to be able to to continue the course when a previous faculty uh, found a new position. And I basically got 10 days to prepare before the semester started when I joined the college. And the course is decently special. The stand of the course is at a middle ground between liberal arts and applied technical education discipline. It was designed, including the timing, was designed to fit the schedule of ATE, applied technical education students, but most of the students registered came from liberal art directions, which means they also haven't decided their direction yet. They're just taking a general major. Here's the course description. I don't want to go into details explaining all the aspects, but it's a decently standard course, focused mostly on energy generation rather than energy policy. And I have taught this course for 3 semesters. One important detail about the background and the standard course is there's no prerequisite or co-requisite in algebra, and students only need to take English to be able to register for the course. And there's some struggling when I first start teaching it. First, I don't have a research background in energy policy, and so that I cannot offer insights from at a level of the really famous Stanford Understanding Energy Learning Hub. And when I teach facts, I'm just talking about facts. There's no follow-up questions I can ask. That's on me. So I have to be able to enhance my technical skills rather than follow some pre-made narratives. And the textbooks we have been using, one is the Energy and Human Ambitions on a Finite Planet, the open resource book by Professor Thomas Murphy from, I believe, UC Berkeley or UCSD. And the other book is the Physics of Energy from professors from MIT. And these 2 books are algebra heavy. But at some level, I have to introduce algebra to justify certain claims, including how to justify climate change. So I do have to gradually add in algebra to make the teaching happen. And there is also a decent amount of derivation. And the struggle, of course, is that students have a hard time absorbing the math, and it is quite impossible to apply the math if the math is doing on paper and pen. But if we do calculator or if we do some kind of computer programming, including the generative AI for data visualization, these are within the skill range of students. But even with that, the bottom line is I should be teaching the learning outcomes rather than what I like to teach or what's good for students. There are 5 learning outcomes I laid out here. And I believe, of course, that's not all of the aspects of the teaching for data visualization, but guided activities on using AI for data visualization can at least, I would say, fulfill at least 3 of the 5 learning outcomes. So the learning activity is relevant to the coursework. So now let's go into the details about several examples of how I do utilize AI for data visualization. So when I say AI is just ChatGPT or Gemini for students, they have free Gemini. So they generate codes from there. One activity is to visualize the mechanical energy spent during driving. And thus, case study was from the book, The Physics of Energy, and it studies the energy spent just from gasoline from driving from Cambridge to New York City. And that's not location based for our college because the book was written by MIT people, right? So the straightforward activity would be to study the case of gasoline energy, mechanical energy spent in driving from our island, from the east side of the island to the west side of the island. What is good about it is our island has 5 volcanoes, and the largest one, a dormant volcano, is actually, if you count the height from the top, the summit to like the bottom of the ocean, that's the largest sea volcano on the earth. And if you model the trip, it's decently easy. I drive there twice every month at least for my astronomy class. I have some telescopes. It's basically just an uphill and a downhill. So we can easily model the gravitational potential change. And however, students cannot do calculation with hand. So what I did is motivating them to put the information of the elevation change, including how high the summit is, into just generative AI, and then describe all the different kinds of mechanical energy and how these are estimated in the case study from Cambridge to New York City. Put all this information in and let the generative AI to give a cumulative energy function. Y-axis is energy in megajoules, x-axis is the distance along the trip, and plot the curves, especially the energy spent from air resistance, rolling resistance, and then downhill braking loss. These are the 3 major ones. There can be another one, kinetic energy from just stopping and starting in front of the stoplights, but we don't have it because it's just it's not an interstate highway, it's just a county road, but there's just no stop signs. And then you plot a curve. Since the elevation is just uphill and downhill, is decently easy, and you can see the trend. If we model the trip as half up, half down, right in the middle, there'll be a change of the slope of the curve for downhill braking. Actually, initially it's just 0 if we model the speed as constant, and then after the summit, when you are going downhill, you got to brake. And then for air resistance and rolling resistance, these two, they just have a linear function because we are assuming the speed to be constant and then the normal force to be constant. And then after that, students definitely got motivated after they successfully created something by themselves to reflect on the mathematical model of energy usage. And then we can analyze why the curves behave this way, right? Including why downhill braking is non-zero after 25 miles. And then by the end, we can also justify whether the generative AI is estimating the energy spent correctly if we convert mechanical energy about totally 50 megajoules to how much gasoline is used. And then we can relate to our real life. How much gasoline do we use driving from Hilo to Kona, which is from east to west. So that's one of the activity. The other activity is to visualize energy consumption by state. In the lecture, this is about lesson 6 to 8. And in the lecture, we computed the average US power consumption per capita with algebra. And basically, we just have the total kilowatt hour that's used by the US per year, and then we divide by the population. We do unit conversion and then divide by time. And the number was justified to be 10,000 watts. And this part cannot be applied after a lecture. So I derive it, but students won't be able to use this to calculate certain other things. They can do a minimal amount during the lecture, but this cannot be the focus of the follow-up because it's really not we don't have the prerequisite and prerequisite. But I do want to extend the discussion, right? So what we do is to visualize energy and power consumption per capita by state because that data really doesn't exist if you search online. Maybe there's like one data graph, two data graph from a data from like many years ago, but we do want to visualize the new data. And the outcome is to make interactive map, both in the energy unit, in BTU, British thermal unit, and also power unit in watts. And here is just a figure of one of the outcome. My guiding question is, if you design a question, if you're the audience and you want to design how to make this happen, there are two things you may consider. One is what can students analyze after generated the data map? The other one is how do you connect with your course career skills to guide students to increase the visibility and readability of the graph? And the graph is interactive, so you can add a lot of elements over here. And I have two links of the outcome. I'll show it by the end of my talk. But one of the common problem in this is generative AI, especially ChatGPT, if I use it, may not generate the correct color legend. For large numbers, ChatGPT sometimes gives like light colors, and small numbers, it gives heavy colors. So you got to specify, you got to tell students that you got to specify like what you want and make the graph look better. And then activity 3 is to study the wind turbine size progression by year. Again, that's my shortcoming that I cannot comment on energy policy on where wind turbine is built, connecting to not only geological based information, but also like policy, economy. I can't really not comment on that. Sorry. So what we do is during the lecture, I mostly derive the equation for wind turbine power, and then we do some algebra. We also focus on explaining what is a cubic relationship, for example. And then we have case studies. We talk about the density, the layout of turbine in a wind farm, and the energy density to show that the power is large or small, right? And the follow-up, again, the follow-up cannot be super mathematical, but normally the follow-up can have some practices on the wind turbine size versus the power. There's a cube relationship. Sorry, not a cube, square relationship. And also for the wind speed, there's a cube relationship. And after that, just for a student individual work, that's hands-on, that's not purely algebra, what I use is making another interactive map using HTML to visualize the progression of wind turbine hop height and rotor radius using certain database. And one available one is the United States Wind Turbine Database. And for the global data sources, personally, I haven't really determined what's the good source. And when I generated this graph, I gotta be frank, there's some data that I just filtered out using AI, and I confirmed some. I didn't confirm all of them, because there's a specific purpose how I want to lay out the graph. And a guiding question over here is how can we make sure that when students make the graph, how do we guide them to make sure the hop height and rotor size are plotted correctly? Since you're doing, for example, you're doing average, you want to make sure that these scales are correct. At least you had the y-axis correct, and these red bars, the red lines for the rotor size has to be to scale if you can make it to scale. If you really can, of course, you can add a description, say that that's not up to scale. But this can be done fairly easily in an HTML file in the code. And I will show that also in a second. And I'm wrapping up the discussion over here. One is that the thing that I also tried, we can also visualize, but it may not be justified just from the data point of view, is the renewable energy consumption pie chart. This chart really also doesn't exist, especially normally if it does exist, it does not have traditional biomass. My understanding is that traditional biomass is not accurately estimated in studies. And also here's an example. I'll show that in a second. I'll show all this HTML files and pictures in one run. And just some tips for effective teaching. So most of the time, if you use Gemini, Gemini can't run HTML codes in the dialogue, and students might be a little bit discouraged if somebody uses ChatGPT, somebody uses Gemini. And to make sure that doesn't happen, you have to understand that HTML codes can run on like an external site, and then students can do copy paste. And my class is fundamentally the liberal art class. I do design some other technical classes, but this class has to focus more on logic and mathematical skill building to some extent. So my class don't have a lot of career skills, but it could be really beneficial if you design class flows to include these career skills. For example, any requirements when you plot a figure and any like layout requirements, that's what I can think of. All right. So now let me just quickly share the files, and these can be also be uploaded, I think, to your platform later. Let me share the files over here. Just 1 second. All right. So this one is the study the visualization of U.S. energy consumption per capita by end use in the unit BTU. And this one is prompt from ChatGPT in 3 sentences. I'm going to visualize the residential data use, commercial ones, industrial ones, transportation, and then total. And specifically, students need to specify that they want different colors to make different sections look better. And also the color legend has to be dark color as large number. Otherwise, it couldn't make sense, correct? Okay, and then the other one is wind turbine. So for the wind turbine rotor radius and hop height, this one can be really interactive. For example, we hover over here on a cursor, can see the details about the date and the configuration, the benchmark, the name of the turbines. And these data, again, some of the data, I mean, all the data exists. I verified those. I just couldn't verify like directly, are those the best ones within the 5 years? So that's also the pedagogy. Like you want to show the data, yeah, but you probably wouldn't want to show a turbine that's really high in hop height, but really small in rotor size. It's just not a good visualization just for outreach, for example. But these are the things to consider. So what data do you filter out? If I use just US data, the data is very hard to justify. And this one took about 10 minutes to generate because there are so many things. The red bars should be to scale, but sometimes it's just really hard to configure. Okay. And then one last one is the one I said that's not really justified. I really would not plot it because the traditional biomass is not estimated correctly. I think after 2015 is in this database, the World Energy, the website, sorry, the World Data website. This data is not updated for traditional biomass since this part. So you see it's constantly decreasing, but it might not. It's a constant number. And this one also just used about like just use about 3, 4 sentences of prompt. And then we can see that hydropower is increasing, is always dominant, apart from traditional biomass, certain things like this. And just for the technical presentation skills over here is you wouldn't want the numbers over here and the names over here, legends, to flow out of the pie chart, and took a while um, to to configure that. All right, so that's basically the talk. Just let me share the last slide and then I'm done with it. So I'd like to conclude the talk by doing a summary. Mahalo in Hawaii means thank you. And I do thank everybody for your participation and your attendance to this talk. Just as a summary, personally, when I use generative AI, I would not to use it to refine the pedagogy in a way that how words are processed, sentences or textbooks are processed. What I use is to enable hands-on activities while fulfilling some learning outcomes. That's one. The other one is to assist with the skills that I don't have, or I'm not willing to put efforts in developing, or I don't have time to work on all these during the instruction. If we configure all the codes and then put data in manually, even partially with AI, we won't have enough instruction time. And if we fully use AI, only put a data set in, we just feed the data and then use AI and then generate a figure and then analyze with logic and reasoning after, I gain more instruction time, but I still have a lot of hands-on activities and we use new data. All right, that's pretty much of my talk. Thank you everybody for listening, and any questions and comments?
Thank
All
you,
right.
Dr. Yu. There is one question I have here in the
Yeah.
comments. Uh, Jason, would you like to ask your question, or I can read it for you?
Yeah, I can read it. I can read. And would you like to read it?
I, well, here I'll read it.
Oh, okay. Thanks.
Yeah, I'm sorry. I'm at a Starbucks right now.
Oh,
Okay.
well, then
Can you
I
hear
will
me?
ask the. I can, Jason. Here, I will ask the question so you don't have to read the question in Starbucks. So, Dr. Yu, the question was: in order to have AI in the classroom, has your college developed a policy or parameters that its use that you've been able to navigate and found? Have you found that restrictive, or how has that worked?
Thank you. Great question, Jason. Yeah, so for Universal Hawaii System, the requirement is that there shouldn't be data share with the AI company. So we had to deal with Google Gemini, and the data is not shared if any information is put in there. But ChatGPT is not working with us. So personally, I generate all these using ChatGPT because I think from my usage, it's a little bit easier when I work with ChatGPT. But Gemini can do similar things, but with more prompts actually. So I hope that answered your question. But just a little comment from my experience is it's still pretty premature with the work of and Google Gemini. And there's also a variety of tools, for example, Google Viz, and also Google, especially Google Viz. There are a lot of functions that are not available to students yet. But we are trying to figure out what are the new pedagogies before students can get access to them.
Dr. Yu, I'll add that at my college, we recently, in this academic year, added to our template syllabus. There's kind of a 1 through 5 gradient of what the instructor allows students to use as far as AI goes in the course, just to kind of lay out, everything from no AI is allowed at all the way to, use it however you'd need to. And so from a course by course policy, that's how our college has done it. But from a college wide, we've done the same thing. We have Gemini as well that students are encouraged to use and have access to.
Oh, thank you, Andrew, for a comment. Oh, for that aspect, yes, for us, it's just course by course determination. Yeah. We don't have for our, at least our Hawai'i Community College, we don't have a guideline yet on like a statement of like um the work ethic on these. But we can add, of course, a paragraph in our syllabi and stuff. Yeah. But it's good for my class, because my class do have a lot of projects. It can be algebra heavy, but students do not have algebra skills. But it's a liberal art class, right? It's not a technical class, so I have to hold my standards a little bit higher. So a lot of times we do have to use a decent amount of artificial intelligence. But I'm just trying to shift the students' reliance of doing all computation like in photomath to like actually do coding and be able to change some coding, learn a little bit component of the coding through the way, along the way.
That makes sense.
I had a question for you. I teach have taught a somewhat similar course at Madison College here in Wisconsin to the one you have, and in similar ways, the students come in, they don't have oftentimes the same math background. They definitely don't have experience in coding, and many of them don't have prior experience in using spreadsheets. So, I know one of the challenges of doing data analysis in this field is just trying to visualize large data sets in a way that, you can capture in a graph. And, for me to assign that to somebody to do in a spreadsheet, it could take them a week to generate something that I might generate in, 20 minutes or something like that. And I'm just curious if you mentioned using Google Gemini. I was just curious if you had used any other AI tools and if you found that some of them tended to be more adept at that sort of data visualization tech sort of task, or if some were better at generating code, that sort of thing. I know there's a lot of AI tools out there. I'm just curious if you've noticed strengths or weaknesses between them.
Thank you. Great question, Ken. That's a hard question for me. Personally, I haven't really explored anything but ChatGPT and Gemini. But there are other like really special pedagogy things that I have tried a little bit. Like one is for me also to create like web-based applications so that you can feed on data or feed on like certain like third-party stuff to showcase the function, basically to make some function happen, like certain functions. I wouldn't specify what, but there's one I think is called Script.io. So those are specifically designed to be able to write a whole web-based application by themselves. So I think if you want to make a large project, of course you want a more specialized platform to be able to generate like the database and also the whole structure of a website or a server by themselves. So but that could be a project scale or like undergraduate research scale stuff. One thing I have been trying to actually encourage myself to start a project would be to feed on some data, all different kinds of database data, like the wind turbine data, and then especially I teach also ocean current waves. All these are small players in clean energy, but it could be relevant to our location. So feed on all these data, like basically the speed of the stream, the data, to have a integrated data set for students to explore which one is the most suitable for our island, rather than just doing estimation. I did phenomenology, so we do estimation all the time. We do like 1, 10, 100 to make sure the magnitude is right. But what if it's based on data, based on simulation? So all these nowadays can also be done, like a really integrated website server like Script.io, I think. I think that's what it's called. Forgot the name of that website, but basically you can feed on data externally without manually putting in data and then visualize it, getting different tabs and do some rankings and stuff. Yeah, I would say those work can be done within a day. Yeah, And I think students maximally normally has just a day to make a project. So yeah. Thank you, Ken.
Yeah, thank you. It's just kind of cool that all these tools are available to students now. It's so much
Yeah.
more powerful than what we had just 5, 10 years ago.
Yeah, definitely. Imagine that we were
Very
still
good.
searching just on Google.
Well, Dr. Yu, thank you so much for sharing the work you're doing, and thank you for taking time to present it to us. We really appreciate it. And I think if there's no other questions, I think that concludes our webinar for today. Thank you all for joining us, and hopefully we'll see you at another webinar soon. Thank you. Bye-bye.
Thank you. Bye.
Thanks, everybody.
Thank you.
Thanks, folks. Bye. Have a good weekend.
Thank you very much, Dr. Yu. That was great.
You're welcome. Thank you, Andrew, Gabriel.